Okay, so the roller coaster detective that I asked you to give a try to, it's very similar to the irregular loop. It has an irregular loop, but this time what the info they give you is different. So we don't know the height of the first hill, but we know the speed at the top. We don't know the radius of the first loop, but we know the number of G's felt and the speed down there. We don't know the radius of the second part of the loop, but we know the number of G's felt and the speed there. We don't know the height of the second loop, so we just have to change up the order that we go in. So number one says, what's the height between A and B? So what's the height of the first hill? Asking for height, you're going to use energy. So 1/2 mv initial squared plus mgh initial plus, of course, the spring, which doesn't exist in this question, equals 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. And it says no friction right on it, so we know there's no E lost and there's no spring. The top of the first hill, there is a speed and there is a height. At the bottom, there's a speed but no height. And so this time we're looking for this height. So take this term to the other side. So, oh, and there's m's in all of them, so they can go. So GHI will equal 1/2 VF squared minus 1/2 VI squared. Divide both sides by G. So HI equals 1/2. The final velocity is 28 meters per second, and you're going to square it. The initial velocity is 3 meters per second. You're going to square that, divided by G. So 28 squared, I don't want to do that in my head. I think you get 39.5 meters for H initial. Okay, so that's part one. Part two says, what is the centripetal acceleration at B? So down here at the bottom, what's the centripetal acceleration? Well, we know AC is equal to V squared over R, and we have V, but we don't have R. So we can't use that equation. But we're also given the number of G's felt. And we know that the number of G's felt is equal to AC over G, either +1 or -1, depending on if you're at the top or the bottom of the loop. In this case, you're at the bottom of the loop, and so it should be, do you remember? At the bottom of the loop, it should be +1. And now you're going to rearrange for AC. So to rearrange this for AC, first step is subtract 1 from each side. And this is the most common mistake, is people multiply by the G first, and now multiply by the G. So AC will equal G brackets, number of G's felt, -1. So the number of G's felt that told us down there was 3. 3 minus 1 is 4. So it's going to, maybe 3 minus 1 is 2. Oh, no, it's 4 minus 1 is 3. There we go. I was already doing the math in my head. So 4 minus 1, 3. 3 times 9.81, and you should get 29.43 meters per second squared for your AC. Okay? The next question asks the radius of the track. Well, now that you have AC, now you can find your R, because you know AC is equal to V squared over R. So R is just equal to V squared over AC. So R is equal to the speed they told us, which was 28 meters per second. We're still at the bottom here, right? Divided by 29.43 meters per second squared. Don't forget to square that 28. There goes my phone. And when you square the 28 and divide, you get 26.64 meters. You can just ignore the phone ringing in the background. Guess they don't know I'm supposed to be working. Number 4 says, it's going to ring one more time nice and loud. Oh, maybe not. How high is location C? So now you're looking for H2. So you're looking for a change in height, and when you're looking for a change in height, use energy. So 1/2 mv initial squared plus mg h initial plus 1/2 kx initial squared is equal to 1/2 mv final squared mg h final plus 1/2 kx final squared plus E lost. Okay, so no E lost, no spring. If we pick our initial, I'd probably pick it down here at the bottom because I know my speed and I know my height there. It's really the spot that's given, and the height cancels out, which is wonderful. And at the top up here, it has both a height and a speed. We know the speed, we're looking for the height. So we're solving for HF, so take your 1/2 mv initial, or v final squared over. I'd cancel out my m, so 1/2 v initial squared minus 1/2 v final squared is equal to, and this is GHF, and now divide both sides by G. So HF is equal to 1/2, the initial this time is 28 meters per second, squared, minus the final this time is 9 meters per second, squared, divided by 9.81 meters per second, squared. And you should get an HF of 35.83 meters. Okay, number 4. Number 5 says, what is the radius of the track? So again, you want radius. You know the number of G's felt. So from that you can get your C, your AC, and then once you have your AC, you can use your V's. So they've combined 2 steps, like the last time they asked us AC and then R. This time they're just asking R, but you still have to find AC. So number of G's felt is equal to AC over G. You're at the top now, so it's +1. So number of G's felt, you're at the top now, so it's -1. And then when you take it over, it becomes +1 equals AC over G. So AC is going to equal G times number of G's felt +1. So at the top it's 2, so 9.81 meters per second squared, and then 2 plus 1, which is 3. Now, coincidentally, you get the same AC here as you did in the earlier part. That will not always be the same, so you cannot always assume that the acceleration is going to be the same at the top and the bottom. It isn't, okay? It just happens to work out that way here. So then AC is equal to V squared over R. So R is equal to V squared over AC. So this time 9 meters per second squared over the 29.43 meters per second squared. And you should get an R up there of 2.75 meters, so a significantly tinier radius. And that's because the speed is so much lower. And then the last question is, what is the velocity at D? So again, you're going to use conservation of energy. Okay, so 1/2 mv initial squared, mg h initial, 1/2 kx initial squared equals 1/2 mv final squared, mg h final, 1/2 kx final squared plus E lost. No E lost, no K. Again, I'd pick my lowest spot down here as my initial, since they gave me that speed, and there's no height there. And then at D, there's both a height and a speed, and this time we're looking for the speed. So cancel out the M's, take your GHF over, so minus GHF equals 1/2 VF squared. So VF squared will equal VI squared minus 2GHF. So it was 28 meters per second where I picked my VI at the bottom of the loop point B, minus 2 times 9.81 meters per second squared, and the height at D was 20 meters. Okay, square your 28. You get 391.6 for VF squared. Take the square root, and VF should be 19.79.